Okay, well, welcome back again to our deep dive into PMBOK, the 5th edition. This module, we're going to talk about planning, defining, and sequencing project activities. And what are the project activities? Those are the detailed work processes that we created back in scope management, where we created our scope baseline, our work breakdown structure, and in particular, the detailed work activities that were in the companion work breakdown structure dictionary. We're going to take those now and finally start putting them into a timeline so that we can start executing the project according to that timeline. Everything we've done prior to this has been a prelude to us finally being able to do this. Risk management's in place. We know quality management, so we know now as they're starting to build these detailed items how we can measure quality against them. We know about all the risks involved. Hopefully you've identified all the risks that really pertain to all these activities so we can monitor them and avoid problems on the project. We have our team in place, of course. We know how we're communicating all this information around to the appropriate people. And our project management plan is becoming more fleshed out, more detailed, more all-encompassing and comprehensive because of progressive elaboration. So, in the real world, we may have started this particular activity here of sequencing our activities as soon as we have had our scope baseline approved. But, of course, with this course, we couldn't do it that way. So we addressed risk and quality in between. So, let's get on then with it with creating our project schedule finally. So here it is. So three of a number of processes within time management, a knowledge area that we're going to address here. Now it's going to create a schedule management plan, how we're going to manage our time and our schedule. We're going to define the activities using the work breakdown structure, and then we're going to sequence them because some may have dependencies on others, a typical Microsoft project chart that you might relate to, which is another reason why you shouldn't start that early. You need to wait until a lot of things are in place. Time management is all about easily managing the timely completion of the project. And here's our process groups. We already mentioned the first three. In the next couple of modules, we're going to look at estimating then the resources necessary to accomplish those activities. We're going to look at how long it takes for them to do it, the activity durations. And then finally, we're going to develop a schedule, which is what your workers will use and you will use to monitor their production of the deliverables, whatever it might be, such as a product, a service or a result transition of some time, or a combination of all of them on your project, especially if it's phased. So that's the purpose of time management. Here's our knowledge area process group grid. The blue ones are all what? Planning. So they're all planning. A lot of planning goes in to the project schedule, which shows how important it is, again, just not to sit down and crack something out. You need to really plan this so you're consistent, concise, everything's covered, and everything's reasonable, and then you can actually develop the schedule after that. Now, you can develop the schedule independent of your cost control. It's not a good thing, but you could. And some organizations may not have that much importance on cost. I worked for an organization. It was a semi-public organization. They didn't care what it cost. They just wanted the schedule, get the work done. Maybe that happens. So you don't really have to do costing, but in most organizations you really want to keep control of cost because you have a budget, and we'll deal with that under cost management. But here's time management. So once we plan everything, we don't execute the time management. The time management goes into our schedule, and you execute it as you deliver the work. So what we do is control the schedule under monitoring and controlling to make sure we keep that baseline intact. And finally down here, 6.6, again, develop schedule, way down there. It's not that big a deal in the overall scheme of how you develop and produce a good project. Although it's of key importance once you do have it. You got to maintain it and manage it. So time management. Time itself is two of the triple constraints of scope and cost. Scope, cost, and time are your triple constraints. Now, these things we're going to have to deal with, and you're going to have to deal with if you expect to be really successful at your PMP exam, because they will quiz you on the differences and relationships of these terms in the PMP lexicon. So look in your glossary. Again, make sure you understand them. Reread time management again. Look at everything. Make sure you understand what these are. So if you're quizzed on them, you can answer intelligently. Schedule data is one thing. The schedule model is another. Okay, the scheduling tool is another. And the scheduling method you use is another concept within this whole environment here. The project schedule is different than the schedule baseline 1 second after you baseline your schedule. At that moment you baseline it, the project schedule and your schedule baseline are identical. But 1 second later, your project schedule changes, and you need to bring it back so that it's in conformance with your schedule. And then the project schedule presentation is yet another concept that is distinct from all these things, and we'll look at those actually right here. Now this is from your PMBOK, so look at it, maybe look along with it, but look here. Also, schedule data. They're talking about project information. All this stuff here. Let's look what it says. Project-specific data, your WBS, your activities, resources, durations, dependencies, constraints, your calendars, milestones, leads, lags, all that stuff is project data. Now what do you do with that stuff? You pump it into a schedule model. And the schedule model, along with using your scheduling tool as a resource, produces or generates as an output finally your project schedule. So it takes the data with your tool and produces your schedule. Over here you have your scheduling method, and these are like your critical chain method, your critical path method, and some other methods that you may use to keep track and keep your schedule in line to the benefit of your project. So all these things together, they overlap in this manner. Now when they talk about project schedule, which is here, it's a living thing. It changes day to day, and hopefully it'll maintain your baseline. And that's your typical Gantt chart or network diagram, whatever you want to see. Here's another example of a schedule presentation. Now is the output that you look at and read. It could be bar charts, activity lists, network diagrams, all that stuff. So, and again, the schedule, project schedule is a living document. Schedule baseline is frozen in time at that point in time. You may be re-baselined later if you need to, but that's what that is. So understand the difference between all these things. Take a little time, research a little more in your PMBOK. Look at this, compare this to your PMBOK so you really understand what these are in case you're quizzed on the differences of them. And by the way, the scheduling tool, as it says here, might be Microsoft Project, Clarity, some HP scheduling tool, whatever it is, that's what they're talking about there. So let's go on. Here we are, 6.1, planning, schedule management. We're going to plan how we're going to do all this. And eventually down here, buried down here in point 2 outputs of 6.6 is your actual schedule. So the objective of time management is policies, procedures, documentations used to plan, develop, manage, execute, control the project schedule. We need to control the project schedule so that it reflects and achieves the project baseline or the schedule baseline. Here's our data flow diagram. Coming in, you always generally have the project charter come in because it's a good sounding board of where you are today versus what they really wanted, and things like really get strange. You may want to talk to stakeholders about it, but it's a good reference point, so it comes in. Primarily here it has the major milestones that the management business side had proposed or estimated way back when the project was first initiated. It's a good idea to look at that versus how your actual time is going to play out here. Once you get all your detailed work activities in there, it may be pretty well in line with what they want, or it may be way out of whack. So you need to resolve that issue with your stakeholders. Say, here's the real world now. You wanted this, they thought this, but no way, it's this now. So you need to work this stuff out if that's the case. And the one and only single output is your schedule management plan out of this process, and it's used in all the other ongoing schedule management activities. It also goes out, see, watch this, to risk. Your schedule has risks in it, so you can identify risks from it. Can we achieve this? Can we, on this particular item, can we achieve this time? And then you may want to perform probability impact analysis, which is quantitative. You may want to look at it from a monetary point of view on how this schedule may impact the cost and cost of your project ongoing. So that's why quantitative is out here too. So the plan, project management plan, primarily your scope baseline, of course. This is your marching orders, because under the scope baseline, you have your scope statement, the official project scope statement of the scope you're going to build. It has your work breakdown structure of all the items that make up your deliverables, and the work breakdown structure dictionary, which of those deliverables, here's how you're going to build those particular pieces, and the time and the cost and the duration to do that. Your project charter again comes in because you may want to get a sanity check against the milestone schedules that are in there way back when. And sometimes, by the way, in these project charters, they may have mandatory milestones. And you'll know this, of course, way up front when you do your charter about these mandatory milestones, and somehow you need to gear your project to meet these milestones somehow. And there's methods of compressing the schedule if in fact you need to do that, and we'll see that later. Environmental factors that play, of course, your culture, people. Maybe they're lazy, to be not rude about it, but what if they just have bad work ethics and they don't perform to your expectations? Well, your schedule's going to slip. So that's a culture problem. You have really no control over these people, other than try to work with them, and if necessary, discipline them to get them back on track, or swap them out via change control, right? Their availability and their skills certainly impact the time it will take them to do certain work. Your project management information system is available to help you do these scheduling activities. Publish resource productivity information. Depending on the type of thing you need people to do to create, there may be information that will help guide you on the durations needed to do certain types of tasks. And of course, your own organizational work authorization system is, if you have one, is how you can automatically go out and assign people to your project, select them and their skills and their availability. I want him, and you do it if that's what you have available to you. Process assets, the usual change control procedures, risk control procedures, templates for things to help you do time management. Monitoring and reporting tools to monitor and report against time. Historical information, of course, and schedule control policies, standards and procedures. I went through those kind of quick, and I may do this kind of quick later on too if they're kind of repetitive, but just to reinforce it, these things are still there, they're still available, and you should always use them if they are available to you. So those are the inputs. We're going to talk about tools and techniques when we come back. Okay, so here's some tools and techniques that we can use to help us develop our time, our schedule and time management plan. Expert judgment, again, if you're unfamiliar, unsure, or you just need the best advice possible to help you do the best job, you call on an expert, either internally or externally, whatever is you're capable of obtaining to your benefit. You do that. Now, there are certain analytical techniques that you need to consider of how you're going to be creating your time schedule. And there are strategic options, what's my strategy to get the best time management schedule and plan out there. The scheduling methodology you're going to use, we'll talk about what that is when we get actually into creating the schedule. The project management software you're going to use, the capabilities of it. You need to be very clear on what you expect of this software so that you don't use one that doesn't provide the capabilities that you need, or it's so too cumbersome or buggy that it's giving you all sorts of problems. You want to choose the right one, and hopefully you'll be able to piggyback off the project management software that's already available to you in your organization, either ad hoc or via your PMO, project management office, if you have one. There are certain estimating approaches you can take. We'll talk about those later. And the formats of the way you're going to produce, say, your schedule presentations, your audience, who's going to see these things is all part of your communication plan then. Also, your stakeholder management plan, what they're going to see, and in general, just what's it going to look like, how you're going to use it. Fast tracking and crashing are two techniques you can use in your schedule to shorten the duration of your project. And if you're able to do those, there are two different kind of techniques that we'll talk about a little later too. You need to actually detail those out under what circumstances and how you intend to use those. So that's a good thing to put in your project or time management plan. Again, all these things, the methodology you use, again, the methodology could be you can use CPM, critical path method on your network diagrams, or critical chain, which is a different concept. And they're really different concepts, the way you manage time, and some are more appropriate for a type of project than others. So you need to consider which one you want to use and then stick with it. Or actually, if your phase project, you could use critical path on one phase and then go critical chain on another. You may want to use agile kind of project management, time, develop stuff and produce them perhaps. But whatever it is, it goes in your time management plan. And all these affect risk. What you decide here has certain risk components, and you want to put those in your risk management plan and your risk register. Of course, as you're fleshing all this out and making all these decisions and creating your time management plan, you will have meetings. So planning meetings to develop the schedule management plan. You want to make sure everybody's on board because they're going to have to comply within the bounds of your plan when you actually start producing your schedule and managing it. Output, the schedule management plan, and nothing but in this one here. So here's one where there's a single output, which is your plan. What is it? A lot of things. The schedule model, the development and the maintenance of your schedule model, the level of accuracy that you expect in it, units of measure you use in there, is it a monthly, weekly, whatever it is, organizational procedures, links, maybe there's some procedures that help you, they're obligated by your organization that they expect to see in your time management plan. Control thresholds, schedule performance variance. In your plan now, you need to define variances in the performance as you get out of whack. You define, what you're going to be looking for and how you expect to manage those. determine when actions will be taken. Now here we finally see officially, and we'll see more about this throughout more of these time management slides, is your performance measurement baseline rules. What are those rules? What does percent complete mean if you use it? Percent complete, many project management practitioners think that percent complete is a useless metric. It doesn't really mean anything. You can be at 99% complete for weeks, where in actuality you were at 70% beginning. So it's kind of meaningless. You need to have rules on how you use the percent complete where it really makes sense on your project, if you're going to use it at all. Earned value management, not values, earned value management techniques is used with time. Primarily it's a cost technique, but it also applies with time as far as forecasting time and whether you're going to be on time, within your time constraints, or earlier or later over time. It's a good technique for that. We'll see that. Control accounts, remember, you have your detailed work items that you're going to build. They roll up into a work package, and work packages, you have several of those here maybe. They roll up into control accounts where you aggregate costs and time and durations and things that roll up, further up, so you can account for everything at the top. What are those control accounts? You need to set those up in the plan and how you're going to use them. And here we have schedule performance measurements. SV, schedule variation. SPI, schedule performance index. Now these are actual earned value management metrics right here. SV, SP, there are more of them, but in the time context, we're going to consider these. Process descriptions, reporting formats, everything's in your schedule management plan. So we're going to come back in a minute and talk about actually now defining the activities that will become part of our time plan. Okay, here we see the time management knowledge area overview diagram. And we've already done 6.1. We've developed our schedule management plan, so we know how to deal with all the rest of this stuff. I've circled 6.2. That's what we're currently going to talk about, that process. But I also put in yellow, as you see here, 4 activities. Why? Well, let's just look at that a second. One of them is we're going to define the activities, what we're going to be doing, and we get that from the work breakdown structure and its work breakdown structure dictionary of the individual, how I'm going to build something. Those are turned into activities that go into your schedule. There's a one-to-one relationship there. And so we're going to define what those are by looking at the scope baseline. In 6.3, or here, we're going to then sequence them in an order so that they're done in a logical manner. And there may be dependencies where you can go up this far, but you have to wait until this guy over here gets done, and then you proceed here. And there may be leads and lags involved too that are arbitrary constraints. Okay, but we'll see that. That's your sequence activities then. Now notice we don't have any time involved here yet. We're just sequencing the activities without regard to how long it takes to do them. In 6.4 over here, now that we've sequenced the activities, you know in what order these are to be done and where all your constraints and dependencies are, then we assign people to them. And we assign resources to them, like materials. So here's an activity. Bob's going to do this. We don't know how long it'll take him yet, but he's going to do it. And to do this, he may need 8,400 tons of concrete or something. So resources, but basically it's people. Now you assign people to these tasks, and they're most likely and should be the same people that are in your work breakdown structure dictionary, because there you assign people to it to do that work. They translate up into your schedule. Now finally, over here in 6.5. We finally here now assign the time, the duration it takes to do these tasks. That's when all of a sudden your schedule starts to stretch and do all these crazy contortions, and now you have a duration for your full project. Finally, you do it there. And then later on in 6.6, we do some magic in there with all of these 13 inputs, bunch of tools and techniques. And way down here, finally, in point 1 and point 2, we have our project schedule. So you got to do all this stuff. It's preparatory. It's necessary to have a good, clean, concise, manageable project schedule. So let's look at the define activities. The schedule management plan, of course, comes in, helps us do our work here. The scope baseline is fundamental because it has the definitive list of deliverables that we need to do down to the work item level. What I mean by that again is, let's say you're building a thing here, and you have to do this process, put it here. You got to do something over here. It takes you 2 hours. You put it over there. You attach it to that, and you do another thing. Takes you an hour to do. You fit it in there, and now you have this thing done here. Okay, that is the kind of thing you're going to put in the schedule, so you know what you're doing and the sequence you need to do it in. So scope baseline, deliverable requirements, definitive. Decomposition is addressed again. Remember, that's how we broke it down. We may need to do that again and review that to make sure that what we're doing in our schedule really reflects what has to be done to the right level. Because you don't want a task in there that's too broad, And you never want a task that goes beyond, a week maybe, if possible, because then it becomes a little more unmanageable and unpredictable. So you want to get it down so they're discrete tasks. Do it, you're done, quality check it, great. Put it over here, do the next one, build your deliverable up that way. And rolling wave planning, again, is at work, progressive elaboration, because even though you can schedule stuff early, you have good durations. I know it's going to take this long. Out here, we're not quite sure yet because a lot of things that happen here may impact how long it takes to finally do these up here, so you estimate it. But now as you complete these things, you look up ahead, and as they come in closer, you define them better. So then they're actually more precise, rolling wave planning. So here's our our data flow diagram. Now as you look at this, everything here, a little question down here. If, at first glance, is there something missing here? What do you think? Here's inputs. There's no outputs externally. Nothing goes out of this process externally. It's all internal. You're all doing internal stuff as you're creating your time, your activities, as you're sequencing them, as you're assigning resources. They're all here, right in here. Nothing external cares about this yet. So it's all internal. So schedule management plan, and the big item that we need to see is the scope baseline, because that's your detailed definitive work items. Output are a milestone list is a distillation of the entire schedule activities, and you'll have milestone lists eventually that help you sequence activities. And the actual activity list that will be in the schedule is a product of this, and the attributes of those activities are also attributes, and they're all used internally to then sequence your activities, estimate durations, assign your resources, and finally develop the schedule. So your inputs, schedule management plan, your scope baseline, which are explicit requirements that you need to build. WBS, it's deliverables, it's dictionary. Constraints and assumptions are in there too. And constraints and assumptions, as you're sequencing, would help define dependencies between things and leads and lags. Environmental factors, your culture, again, may have some bearing on how you eventually assign time to these things, or even define the activities depending on the skills of your people. You may have to have very detailed work items sequenced if that's what it takes to get good quality, versus if you have very skilled staff, you may be able to have work items that are more aggregated, and your skilled staff just knows how to build those without having detailed plan stuff. So it all depends. And of course, your project management information system helps you as you create your sequencing. It'll give you whatever you need with outputs and so on with your network diagram. That's what they call it. If you sequence your activities as your network diagram. Lessons learned to help you do this, policies, guidelines, procedures to help you do this, look at those. Tools and techniques. Decompose the project scope. We've done that with the WBS. You want to look at it again, make sure everything's good, it hasn't changed or anything. So you decompose activities to represent the effort. Effort is time. The effort needed to complete your work package of deliverables. Again, there's no resources yet on here, there's no costs. There are yet no durations. This is just activities. Whatever you need to do at this point is all we're dealing with. Again, rolling wave planning is at work, like we mentioned. And again, expert judgment should be available to you to help you if you have any problems or issues or whatever when you're doing these tasks. Now the output, primary output, is the activity list of your work product here. All product schedule activity, or all project schedule activities are considered. Everything you need to produce the final products are in your activity list, which are direct translations from the scope baseline and your work breakdown structure. They're translated into your project schedule. Some of them may be aggregated together. Remember, you have 4 work processes, detailed work processes in your breakdown structure. Those 4 may end up being one activity in your plan, possibly. So however you want to do it, but 100% of what's down here in your work breakdown structure has to be represented somehow in your project schedule plan. Every one of the activities, just like your work breakdown structure, and in fact they could even have the same identification, needs to have a unique identifier and a title, which is what you see in your project printouts, for example. And of course, the scope of the work, the description of the work you're going to do is part of the activity list, which would reflect pretty much what's in your breakdown structure. The attributes, and here are some of those things elaborated here. The activity is WBS ID. The name of the activity, the description, whether it has predecessors or successors. This has to, before I do this, this guy has to do this over here, and likewise. Leads and lags. Now, predecessors and successors are I don't want to say mandatory, but they're a natural thing. I got to do this before this, and I have to do this before this. But you may arbitrarily, at your discretion, introduce a lead or lag. That means, okay, I know I got to do this before this, but I think I could maybe lead it or lag it and do these kind of things. It's arbitrary, and you do those things to try and affect the end date, the full duration of your project. Maybe try to compress it by doing things like this, and then we get into crashing, schedule crashing and fast tracking that we'll talk about. But leads and lags are arbitrary, up there at your discretion. Resource requirements, who's going to do it? That's part of the whatever that activity is, you have to assign a resource. If you have imposed dates, remember, like in your charter, some governmental mandate, you shall do this by this time. Well, I got to do this work item, you got to be done here because so-and-so says so. The level of effort, here's where you get the time that you need, whether it's a discrete time or a portion between people. The project calendar that is used, that this item will be used within is specified as an attribute. And where the work is performed is also a consideration, and of course by whom. All these are attributes. And then the milestone list, finally, it's a significant point in the project, mandatory, similar to activities and structure and attribute, your milestone list. Milestone durations are always what? 0. A milestone is always 0. It's a marker in time that you need to meet. Whether you use them is optional, but you may have reason to put a stake in the sand and say, here's a milestone, we have to meet this date. So we have defined the activities, translated them from our work breakdown structure into a scheduled network diagram without consideration for the time it takes to do those or the costs or the resources applied. So we're going to look at that next in our next activity. Okay, now we've defined the activities that will be components of our project schedule eventually. In fact, we're building our project schedule now with these activities without regard so far for cost, resources, or time. So now what we're going to do is we're going to sequence them. We've defined them. You might say they're all in a bucket, but now we're going to define them and sequence them one after the other, whatever it takes to build them in a logical order. That's 6.3. Here's our Ito diagram. So sequencing is defining the relationships between all of these activities so that they're arranged in a logical order of work so that you can have the greatest efficiency considering any project constraints that are in there that result in what we're going to call an official word, your official lexicon item here, the project network schedule diagram. Okay? This is not a Gantt chart. That's a different animal altogether. This is your network schedule diagram that portrays the sequencing of activities irregardless of your Gantt chart. Although the Gantt chart uses this information to produce a Gantt chart, but they're two different things, so don't confuse them. We'll see why here. Here's the data flow diagram for it. Here's our sequence of activities. We have our schedule management plan come in, but the big player here is the activity list, because these are the activities we're going to sequence. And of course, the attributes are definitions of those activities. And the milestone list, if there is one, comes in too, because that's critical. We have to sequence that properly in the right place. Also, the project scope statement comes in with its WBS as a sounding board to make sure that we've not missed anything. And that's basically it. And the main output is the project schedule network diagram. Okay, and then, and only then, can we really develop the schedule. So, key inputs: management plan, activity list, the attributes, milestone schedule, milestone list. Scope statement, have the scope description, characteristics that may affect sequencing. You may have some characteristic where it needs something before the other. You can glean that out of here and account for it in your network diagram. It shows, of course, all the project deliverables, constraints, and consumptions that are going to come to bear here with how these things are sequenced with each other. Industry standards and how you sequence things. Your tool, PMIS, is an input that you're going to use to do this. The actual scheduling tool itself, like Microsoft Project, or if you have like a suite of project management tools, you will use the scheduling engine to do this, whereas your overall project management information system allows you to do other things at other points in time, like produce reports and do that, all that kind of stuff. And your work authorization system may have some bearing on how you sequence these too for some reason, so we'll see about that. Process assets, your project file, you can always review them, see how other projects have done it. Activity planning policies, activities, there may be guidance for you to do this right, and you may have templates that will help you create your activity diagram. So, tools and techniques. So here we go with this. We talk about sequencing. We're going to be talking about precedence diagramming methods, PDMs. Again, in a PMP exam, they may call it, what are you doing when you're using the PDM? Well, you're sequencing activities. So you need to know what PDM means, precedent diagramming method. And those mean these four kinds of things: finish to start. When this finishes, this next one can start. Okay, that's the most common way, obviously, of building a network diagram. If all things being equal, you do this, and then you do this, and then you do this, finish this, start this, finish this, start this, FS. You'll see those abbreviations too, sometimes instead of the words finish to start, so you need to know FS, finish to start. Most common one. You could have a finish to finish. You know, this one finishes when this one finishes. That kind of thing. Start to start. When this starts, this one starts. And the least common is kind of strange, but there are reasons to use this. Start to finish. You know, you can't start this till that finishes and things like that. So we'll see these actually in a bar chart kind of thing. Here you'll see exactly what these mean. And here we go. Now you also need to know this. AON, activity on node. This stuff gets kind of particular, kind of tricky, so you need to understand what we're talking about here. Activity on node, or you may just see it AON, uses boxes to denote schedule activity. Okay? Activity A finishes, activity B starts. Okay, here you go, look at this. Activity A starts, same time activity B starts. Okay? Watch this. And these are called logical relationships also, by the way, logical relationships. Activity A finishes when activity B finishes, and vice versa. And you have this one. Activity A starts when activity B finishes over here. 4 kinds. And these are also depicted in a bar chart kind of thing that we'll see here in a minute. But these are called nodes. These activities are nodes. So the activities, the boxes or the nodes, are connected from beginning to end with these arrows in these 4 types of relationships that are called logical relationships. You need to know these terms, what they mean. So logical relationships of the dependencies between these activities. And there's reasons for these in the way you execute your work. You may need these things, and you will need at least one of them, at least finish to start. And then these other ones are a little more sophisticated, but they may be necessary to build the proper deliverable in the proper sequence, given a lot of other variables. There's another one called activity on arrow, which you may come up against in your PMB exam. Now the circles now denote milestones, completed milestones, where here the arrows are the tasks. Remember back here, we're talking the boxes are the tasks with your relationships, and here the arrows are the tasks. You have a milestone here in A. You do an activity B to reach this milestone. Okay, this is arrow on activity, or I'm sorry, activity on arrow. So the activity is on the arrow, and the circles are milestones. So, or tasks. Activities, tasks. You got all A, B, C, D, E, F, those are all tasks. Your milestones are there. Sometimes you have things called dummy tasks because you don't really have anything happening there, but the milestone here is related or dependent on this milestone here. So here's these dotted, even this great big one here. Nothing happens there, but you need to link it because when you are finally done with this milestone here, nothing else to do. So you wait until the end and all these other things are done. So keep in mind activity on arrow, the arrows are the activities, circles are milestones, and you may have dummy tasks or dummy arrows. So if you're confronted with those on the exam, you need to know what these are. How do you determine dependencies? You could have mandatory, milestone dependencies, or discretionary at your own, which would basically be leads and lags. Internal, well, let's look at these here. Then mandatory. Legal, contractual, and just inherent in the work, you may have milestones. It's different from scheduling tool constraints. They're imposed dates. Discretionary, best practice, preferential, soft logic, they call it in the PMBOK. It causes problems with float and fast tracking. You don't want to be discretionary with anything you do. You want to try and avoid that. You want to be very precise with what you do, and this will become clear as we go through here. You have internal and external dependency determination issues. Internal is within your project control. You can manage these dependencies. External, like an imposed date from a government mandate or something, you have no control. External. So here's leads and lags. Now again, your schedule logic is your finish to start, start to finish, and all that. These are where you can do this. You can advance a task that was this one here that I'm pointing to here. This is a finish to start dependency, logical dependency. So normally it would be here and go out this way, but for some reason, whatever you need to do, because maybe you're trying to compress the schedule or something back here, right here in this first one, once you get this far in your completion of this particular task, you may then actually be able to start the next task. So you put a lead in there of this thing so that it starts earlier. It's still finished to start, but you can advance it earlier. A lag is the opposite. The successor over here is delayed later than the predecessor, so you can move it out farther to add time in there. Okay. Depends on logical relationship dependencies, that's what I just said, and it does not replace these, it augments them, and they're generally arbitrary for you to make sure things work in the right way. Your scheduling tool will put in whatever you want as far as start to finish, finish to start, those 4 logical dependencies, but it has no idea whether you want to lead or lag anything. So you need, that's why I said, that's at your discretion. You put those in yourself. And this just shows how these things work. Here's task A, here task B. This is a finish to start. Right there, finish to start. Here's another one. Here's one with a lag. Finish to start, but you're lagging it out. Here's finish to start with a lead. You're bringing it back in this way. Finish to finish look different. Here's a normal finish to finish. You finish this, it has to happen at the same time. It doesn't have to start at the same time. This could have been a shorter one here, but still it has to finish at the same time as this one. Now you can impose a lag where this finishes up here. Now your scheduling program wouldn't do that. It wouldn't know you want a lag. It just knows that this has to be finished when that's finished. And a lead with finish to finish, it would be this direction. Start to start. When this one starts, and again, they don't have to be the same length, duration, each one of these tasks. I mean, this one here could end here because it's a short one, but they got to at least start the same time as this one. To impose a lag, this one starts, but you need to wait for this one to start some period of time for some reason, and you impose that reason. And a lead would be this starts when that starts, but this one's going to start before that starts, but still it's a start to start. And finally, we have our last one, start to finish. This one starts when that one finishes, and you can put a lag in. It moves it this way. You put a lead in, it moves it that way, although your logical dependency is not interfered with. So you need to know what these are, the impact of imposing leads and lags on the dependencies, depending on which of the 4 dependencies you're talking about. You just need to know that. There will probably be actually diagrams like this in the PMP exam that say, what is this? You look at this, you say, okay, that's a start to finish, and it's got a lag in it. And that'll be one of your options in the questions to answer. So you need to know what these are based on the type of dependency up here. Okay, we're going to talk about lags and dependencies in a minute. We'll just give you a little breather here, and we'll be back in a minute. Okay, now that you've caught your breath after that rather detailed discussion, which again, looked like these kind of things, I'm going to here condense them down into just the bare basics of what a lag is, depending on the 4 dependencies. So you can see finish to start, finish, finish, start, 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 finish. Lags, how lags affect those various 4 dependencies here in a sort of a condensed form. It doesn't look difficult. You just need to understand how you can recreate these on paper, and you should do that by hand, so then you finally get an understanding, or actually not more than understanding. When you're confronted with this kind of diagram, which you might be on a PMP exam, you will be able then to answer your question accurately and effectively. It won't, the old deer in the headlights thing, like, oh, I don't remember it like that. So do these by hand a bit, quiz yourself on these, and just do them, and you'll be pretty good shape for the exam when they throw these questions at you. Now these are the lags. Here this is lagging. Again, here are the leads. Same thing, finish, finish, or finish, start, finish, finish, etc. But the lag. So you just need to know what these are, how you would draw them, so when you see them in an exam, if you were to see those and they gave you that kind of question visually, you'll know what these things are. So, dependency, determinations, leads, and lags. Here are our outputs, finally, of all of this. We take our schedule, our activity list, we put them in order, we sort them all out. We say, here, these things have to go before these to get things done right. There may be milestones imposed. So you put something in there which is 0, so it's really not time, but you can put milestones in there. And we haven't assigned time to these things yet, right? But you sequence them out, you put arbitrary leads and lags. You may not do it now. You may wait until, and you probably would wait until you actually assign durations to these tasks, which we're going to do coming up here. And at that point, it may be most appropriate then to manipulate your schedule by putting leads and lags in to accomplish your end result, whatever's appropriate. But at this time, at least, we have the basic sequencing of our activities. Every one of them that's in your work breakdown structure are in there. And again, you may take 500 detailed work activities, and you may end up with 100 activities in your diagram because you've been able to aggregate some together and do them all at once in the schedule. It's possible, But worst case, not the worst is the bad word, but the most verbose network schedule you can have is that it reflects every one of your detailed work breakdown structures in your network diagram. And here's what the network diagram would look like as a product of your project management information system and of its scheduling tool. Would produce a network diagram that looks like this. obviously this is a project, right? And day one, minute one, we said a project has a definite beginning, has a definite end, a definite start, a definite finish. So here it is. And let's assume that we had an extremely small project and it had just these activities to do. This would be your network diagram. And we don't know how long it takes between A and B to do this. We don't know any time. We don't know who's going to do it yet. We don't know how much it's going to cost to do this, but these are the pure activities only, ready to assign those attributes to. So here's all your dependencies. Here's a finish to start, your most common. Now it gets complex because here you have B, activity B starts after A, and it has to finish before C can start or E can start. But also, when B is ready to go after A is done, C now can start together with it. You don't know how long these are going to take to do once they start, but that's the logic, that it can't start until this starts. And here you have a lead here, or a lag. You're saying F can start when after F finishes, G can start. Normally, they would start immediately. You know, all these start to finish, finish to start, wherever they're logically connected, you assume that when that start or finish happens in an activity, the next one starts immediately, you know, right then. But you may need to arbitrarily impose leads and lags like we did here. We said when F is done, G can start. However, it cannot start until 15 days later. That's what this is saying. It's a lag. Here we're saying H, when H starts, I can start, but wait 10 days. So that's a lead. Okay, that's how all this stuff works. And this can be extremely complex. That's why you don't want to be doing this stuff by hand. Okay, you want your project management tool and its scheduling component to do this for you. You enter the tasks, you enter the dependencies, you enter the leads and lags, and it'll draw your diagram for you. So this can be incredibly complex. And then you would need to talk about your scheduling method later on, which would be, you know, how long finally does it take from here to beginning to the end? If it's too long, can we compress that? There are ways of doing that. You know, moving E to be done concurrent with D may shorten some time. Maybe we can reduce the time it takes to do F and shorten. There are techniques you can use if you can on your project to adjust the end date. Critical path method, critical change, a little different. We'll talk about that. But this is what a network diagram looks like. You still don't know how long it's going to take, but these are the pure activities, and they are sequenced. See up here? Sequence the activities. That's what we're doing. That's all we've done so far. But at least now that we have this, assuming you've been diligent in it and all your work items are in here somewhere, now we're going to go ahead later on here and assign the resources to do it, and finally the time it takes to do it. So because of all this, our activity lists will be updated, the attributes will be updated and all this stuff. Milestone lists may be evident in here. They'll be in there, and of course risk register may be updated with additional risks. Why? Because maybe, you know, you're waiting 15 days. I'm not picking on a lag in particular, but let's say this lag says we need to wait 15 days because a prime supplier can't give us what we need so that we can complete this G item. Okay, so it's a risk to your end date, assuming this may be on your critical path, which we'll see about later. But it may be a risk at our end date if we don't get what we need in 15 days. So maybe it's 20 days, maybe it's 30 days. Maybe they go on strike and we don't know when we're going to get it. It's a risk. I mean, all of these things can be risk, but leads and lags are generally in there to compensate for some abnormality that you need to adjust your schedule for. So that's that. So that's why your risk register is involved. So network schedule diagram is the result of our activity sequencing. So that's the end of this module, but we're still deep involved with time management. So we're going to come back next module, and now we're going to assign the resources that we need to accomplish those activities. And then finally we're going to say, you know, we're going to determine how long will it take to do those. And then finally we'll be able to say, if we start on this date according to our network diagram and all the constraints and dependencies and durations we've estimated, we're going to end up this date. And finally you'll know when you start and when you end where you're at. And then you deal with it from there. So we'll see you in module 20.